Hello, everyone. So I wanted to discuss the lab for this week. So basically, guys, for this week, we're talking about the chemical and physical properties of the organic molecules. And at the same time, we'll also be discussing, looking at the inorganic molecules so that we can compare and contrast. So in this lab, you will be watching these two videos, which, provide you with all the observations for this experiment. And you are provided with this handout just like every week. This has the data table where you look at all these molecules, you draw their structural formula, you will find out their molar mass using the periodic table, and then you will be looking at their boiling points. Okay, and that information can be found online as well. So now, when it comes to the submissions for this lab, we have got, the pre-lab, we got the actual experiment data, and then we got the post-lab questions. Okay, so for the pre-lab, guys, basically you guys are answering these questions. This is just drop-down menus. This gives you the list of all the compounds that we were talking about. You see with water here, we got ethanol, we got sodium chloride, we got octane and acetic acid. Different types of molecules. We got organic molecules here, we got inorganic molecules here, and you're going to be defining that here. Remember, when you have carbons in the backbone chain, as the backbone of a chain, then you're dealing with organic molecules. Otherwise, you got inorganic. Okay, so you also going to give your reasons here why you think you got organic or inorganic compound. Okay. The solubility, in the water can be decided by using the videos that are provided in this lab. The next question, guys, is saying, okay, how do you put these molecules that are given here? How do you classify them? How do you classify the boiling and melting point because of these molecules independently? So look at the part A independently from part B. There are two separate questions. So you're looking at butane, octane, hexane, dodecane. So basically the question is saying, if you got different, you see all of these are alkanes. Butane is a 4-carbon alkane. This is 8 carbons. This is 6 carbons. Dodecane is 12 carbons. So dec is 10, and dodecane is 12 carbons. So basically you're deciding that when you increase the carbon chain length, how does that affect the boiling or melting point, guys? We have discussed this in the physical properties of the organic molecules in the lecture videos, where we discussed that the intermolecular forces, like the van der Waals forces, are what decide, the boiling point of the molecules. For organic molecules, usually they're van der Waals forces, which are very weak forces. But then if you have functional groups like alcohol, or whenever you see carbon-oxygen bond, those molecules gets the opportunity to do dipole-dipole interaction or even hydrogen bonding, like in the case of alcohols, which have the OH bond. So you will be deciding here that based of the length, which molecule will have, you go from the lowest boiling point to the highest boiling point, and you submit your answers here. Similarly, for alcohols, you will be deciding based on their length, which one should have the lowest boiling point and melting point, and which one should have the highest boiling and melting point. Okay, and you must explain your answer, like how does length affect the boiling point of a molecule. Okay, so you must explain that here. Then, the next question is just asking, it's a very simple question, just asking if these compounds that you see here, if they're alkane, alkenes, or alkynes. And what are aromatic compounds, guys? Aromatic compounds, we covered benzene in one of our lecture videos. The benzene molecule is what an aromatic ring typically looks like. So if you have any molecule which has this ring-like structure, and you have like different attachments on them, that does not matter. As far as you have this ring-like structure, which has these alternate bonds, you got an aromatic molecule. Okay, aromatic from the word that they have smell. So they form vapors very easily, and you can decide of these molecules which one is which. Okay. And then at the end, you're just drawing the structures for all the molecules, these here, and you upload your PDF. Okay. Then you will move on to the observations, the actual report sheet, and you'll be filling in your answers here. Some instructions are given here, make sure you read them carefully so that you're inputting your answers correctly here so that Canvas can automatically create them correctly, okay? And if you still, once the lab is created and you see any point has been taken out from Canvas because it did not understand your answer, in rare cases, if I see something happen, something is wrong with the Canvas, I will fix the point. But you want to make sure that you are inputting the answers like it is mentioned here in these instructions, okay? So for all these molecules which are given here, you're writing down their chemical formula first, then the type of bond that you think they have, like covalent or ionic. So you can typically think that organic molecules have covalent bonds and inorganic molecules have ionic bonds. Then you tell what the physical state is. Again, you will watch the videos which are given to you here, and they will actually show you all these molecules, and you guys decide what their physical state is, whether it's solid, liquid, or gas. And at the end, you decide whether it's organic or inorganic molecule. Going next, you have to answer here whether you think all these molecules will be like NaCl or toluene, if they will be soluble in hexane, water, which one out of these two. So guys, we got two types of solvents. So solvent is, the majority of the component of a mixture, okay? So if by mixture, by a solution, what do we mean? A solution is made up of two things, of solvent and solute. So if I say that I have water sitting here, H2O, and then I add a compound here. So I add, so for example, I add calcium chloride. Okay, so anything that I add. So anything that you're adding in small portion is called solute. So this guy is going to be solute. And whatever was already sitting in there, the majority of the solution is the solvent. So you can have a water solvent, or you can have the other solvent, which is mentioned here in this in the lab. The other solvent is hexane. So let's say in the other container you have hexane. So if hexane is the solvent here, this is hexane, you can tell it's an organic molecule. So it's an organic solvent, and water, it is basically, water itself is a solvent and it is considered a polar solvent. And hexane, it's an organic molecule. It is considered non-polar solvent. So guys, if the molecule you're dealing with is soluble in water, it indicates that that molecule must also be polar. And on the other hand, if you take a solute and you add it into hexane and it mixes, it tells you that this solute must be non-polar as well, because it is mixing in a non-polar solvent like hexane, which is an organic non-polar solvent. Okay, I hope that makes sense. Okay, now that's what will help you decide here your answers, okay? And organic or inorganic will be decided based of what your results are on their solubility, whether they're soluble in hexane or not, and water or not, okay? And you guys will decide which one should be which. Then the next here is you're just answering the same thing. For propanol, you tell me if it's soluble in water or not based off the videos, and then decide what functional group do you think. I mean, from the name, you know what functional group we're talking about, and you'll be just answering this, okay? The next is the combustion problem. You will watch the videos and tell that when they take sodium chloride and put it in fire versus hexane when they put it on fire, whether they were flammable or not. If it catches fire, that's flammable. If it's not, then it's not flammable. And guys, whether it's organic or not, you should be able to tell that by now, okay? You will see that organic molecules are highly inflammable and inorganic usually are not, okay? Now, this here is just asking you, when you take hexane, this is the molecular formula, what observation do you see? Like what happened in the video? Did it catch fire immediately or nothing happened? So that's what you're going to be putting here, okay? All right. The next here is you're filling out this table, the same from the top, but then you see if something happened, if something caught fire, you see, then you know that reaction happened. If nothing happens, then you just say no reaction happened. Okay. All right. Then you got some more reactions, which are again shown in the videos. So if the reaction happened, guys, you will see a color change. So if you see a color change happening, then you know that the reaction happened. If there's no color change, or you see no bubbles formation, like no gas was formed, no color was changed, no fumes were given off, then or no solid formed, these are the indications that reaction happened. If they are formed, a reaction happened. If none of that happened, then we know that no reaction happened. Okay. And then at the end, you'll just putting in your structural formula, molar mass, and boiling point PDF. This document, you're going to be uploading that here as the final and question. Then the last thing you guys are working on are the the post-lab questions. Here, you're reviewing what you have done. So here, these are some conceptual questions. Again, the lecture videos will also help you here and also performing this lab. So the question says, what happens to the alcohols? How does the size of the alcohol? We did this in the pre-lab as well. So from the experiments, how do you think the different alcohols behaved when they were added into the water? Like which ones were more soluble, which ones were less soluble? Okay, and then from your understanding, you're going to be also explaining your answer. That why do you think what observations you're seeing? Why is that happening? Like if you see that bigger molecules are more soluble, then explain why. Or if you saw that the small molecules are more soluble in water, then explain why that must be happening. Okay. And there is a lecture video posted, guys, on this, so you must watch that for the the physical properties of the organic molecules. Then you got this observation table. So organic compounds and inorganic compounds, you're comparing what type of bonds they have, whether they have high or low melting point, whether they're inflammable or not, whether they're soluble in water or not. So that should be pretty straightforward. Then the question you got next here is you list the 3 experiments that help you distinguish organic and inorganic compounds. You can use any 3 experiments that were done that help you decide whether any molecule is organic or inorganic. Okay. Now, this question right here, it talks about the chemical reaction. It says when you take hexane and the combustion takes place, we'll be covering this later on in a later semester. Later chapters in this semester. You will learn how different chemical reactions work. So for right now, I'm keeping it 0 points, but we will be learning this in the future. So if you want to answer this, you can. But if you don't, I'll not be taking any points off. Okay. Then we got based on the observations, what type of bonds do you think there are in hydrocarbons when they are supposed to react with bromine and potassium carbonate? So from the data that you will be provided, from the experiment videos, tell me which molecules, whether alkanes, like single bonded, or double bonded, which means alkenes, which one do you think react with bromine and which ones did not, and which ones reacted with potassium permanganate, which ones did not? So you're basically deciding whether alkanes or alkenes, which one out of those 2 actually participate in a reaction with bromine and potassium permanganate, and give us the evidence, like what happened, what makes you think reaction happened, what makes you think reaction did not happen. Okay, so that is it for this lab. So guys, just for this last this question, if you want to answer it, what this basically is saying, that if you have to do a combustion basically, guys, is when you take a hydrocarbon and you burn it in presence of oxygen, this carbon becomes carbon dioxide and hydrogen becomes water. This is a standard reaction, guys. If you take C2H6 and you burn it in presence of oxygen, you still make these 2 same molecules. Okay, so you are going to be writing down the reactions for these 2 molecules here. You will also have to balance them But again, for right now, I'm not expecting that from you. Okay, we will be learning that in the future chapters. Okay, so that's it for this video. If you guys will have any questions, feel free to ask me or send me your questions. Okay.